Hi everyone, and welcome to today's AMA session. I'm Shubhangi, and I'll be your host for this exciting and insightful event. We have a fantastic session lined up with someone who has not only made remarkable strides in tech industry, but also has a wealth of knowledge to share with us. Today, we are diving deep into a topic that every tech enthusiast wants to know about: how big tech engineers tackle complex problems. And we have the perfect guest to walk us through this: Swapnil Agarwal, a senior software engineer at Google. Swapnil has over a decade of experience having worked on improving tech enterprise search at Google, led engineering initiatives at Setu, built analytic systems at Goldman Sachs. His journey in tech has been nothing short of impressive, and today he'll give us a glimpse into how engineers in big tech solve some of the most complex challenges. Please join me in welcoming Swapnil Agarwal.
Hi, Shubhangi. Hey,
Hi.
everyone. Thanks for the introduction.
So, thank you so much for being here, Swapnil. Before we jump into audience's question, let's start with a quick question to warm up the conversation. So, Swapnil, could you share with us an example of particularly a complex problem you faced in your career at a big tech company and how you approached solving it?
Sure. Uh, I guess like with any problem that we want to solve, um, the first thing that we have to ask ourselves is like, who are we solving this for? What is the use case, right? What is the requirement around it? So this allows you to first understand that whether it's something that the solution that you're designing for will ultimately solve the actual need, right? So that we do not start thinking in direction which is way different from what is required. So this is, I think, the first problem with any domain, by the way. It's nothing about tech per se, happens. And engineers who love solving problems, what happens is they go into their own direction. And then which is what causes a lot of back and forth. So that would be my first learning as a personal experience myself, where we like to solve difficult problems a lot, and we want to, let's say, add technologies that we are very passionate about. Ultimately, to realize, okay, that might have been an overkill and might not have been required to actually come up with. So many a times, actually, 80% times, the solutions that you come up with are simple enough if you think deeply about it, like what we are trying to solve for. So first tip that I would say is, what do we need to solve? What is the actual issue in hand? Who are we solving for? And ultimately, when we think about a solution, how is it mapping back to the original need of this user? I can take an example. So let's say I was actually building a data sync mechanism. So I'm in the Google search team on the enterprise search. So we provide a search system for the businesses to serve in their own private data. But the question is like, it's our stack, but how do we get in data? So we needed some kind of a mechanism to keep the to sync data from the original system, let's say Jira, Confluence, whatever apps that you use, Drive, and come into our index. Now the question is, not only do you have to do it first time, but you have to do it, keep it in sync always. Like how fast? It's a second step for problem. So here we start doing a prioritization. Okay, we want to get the data. Okay, okay. Now, do we want to get it only for one type of app? Is it just documents, or do we want to have emails, or we want to be generic? We could have Slack messages coming in, issues from Jira or any kind of ticketing system, or any documents, or even website content. So then you're like, okay, I want to generate or design a generic solution, and maybe the specificity of how the data comes into is handled by a certain one system, but the rest of the system is agnostic. So that is one design goal that you can think of. But again, this is very a little ambitious. We might want to start simple, and your product manager or your business team says, bro, we wanted to only get it for, let's say, Drive. Why are you thinking about all these things like Slack, Teams, let's say Teams, SharePoint? We don't need. That's your first step, first cue, what we are trying to do, solve for. Now, let's say once we have these requirements, we think about, okay, now that we have the data somehow coming in, do we want to describe what kind of data we want? Do we want to download our entire corporate drive? Maybe not. We might want to just keep, like, let's say, generic content account. Let's say if we are building it for sales team, then only the sales team's data, which is what we want to send. Then do we want to have access controls? Like, so everybody should be able to see that data, or we want to see who owns it or who have the read access. So this is how you start with the requirements. And then once you have these like understanding, you start thinking in terms of a high level idea. Because now that we have a kind of understanding between the business side, what did they need? Now we think about how to design it. Right? Now, what happens is, like, at first point, everything seems very daunting, very scary. Like, okay, it's very generic. Now, by the way, I'm deliberately giving a high level example. Like, complex problems could also be at a lower level where you might want to, let's say, solve. Okay, there are many, let's say, two documents, same thing with the example here, and you want to see whether they are same or not. So here there's not a big system involved per se, but at a lower level, given two documents, tell me whether they are same or not. Now the document itself could be like 10 GB, so don't tell me you're going to start comparing character by character. That's going to be too difficult, too slow. Right? And if you have to do it for 100 versus 100. So that's a different kind of low level problem. So here I'm taking like a larger level system that you have to define. Right? And once you have the requirement, then you think about the higher level system. So what would be a system here? And then one is, okay, some mechanism, so one component which takes care of talking to the third party app and getting the data. One is going to be an API server for you that, okay, it has multiple APIs. Sure, but let's say I want to start keep a configuration somewhere around for the sync, maybe your credentials, right? And then we have a mechanism to start the sync, stop the sync. Maybe you want to add filters. Then, okay, this is the subset of the data I want. So this is your configuration system. Then there is a executor system which actually is keeping downloading the data. Now the question, next thing you could think of is like, okay, there is an executor, there is a configuration, but who drives all this? So then you can say, oh, I might need an orchestrator or a scheduler, which will do it at a frequency, right? Now that might ring a bell in your brain. That, okay, what frequency? Do I keep it an hour, or do we want to have a frequency? I want it to real time. All the data is available in what to search for as it when it is created. Now that's a different thing. Then you're making things complex. So let's start simple. The broad minded says, it's fine. One day is fine. It's fine for the document to be searchable one day later. We are cool. Then you're like, okay, thank you for making my life a little easier. Okay. So you have the scheduler, you have a configuration system, and then you have the actual executor, which actually downloads. And that executor now, as we talked about, could be specific for each app. It could be different for Teams messages. It could be different for SharePoint. It could be different for Jira, which is fetching the tickets. It could be different for Google Drive. But the rest of the system, the configuration, the scheduler, remains the same. The index remains the same, right? Like once we have like a high level design like this, we think about detailed aspects of it. And this is where what happens is, for higher level, like not level, you should say more experienced engineers versus mid experienced engineers, the difference comes into picture of in terms of dealing with ambiguity. That is one. So when we say keep build a data sync mechanism, the senior engineer would be okay, fine. As I told about, these are the different high level components that we need to build. Now you can give that to a middle level engineer. Okay, you know what? Now build an execution mechanism. Don't care about who's calling you, how it is getting scheduled, where the configuration is coming from. Your job is given. I tell you right now. Start us saying this is the config. How would you make it happen? So this kind of boiling down slowly is how you basically start thinking in terms of design, derivability, keeping the details pushing towards more lower levels, but starting thinking reducing the ambiguity. Now, the second aspect of a senior engineer, especially in big tech, in solving for a complex or let's say uh, at a scale problem is failures. So happy paths are always the rosy sunshine, rainbow. Okay, hey, okay, it's a bug. But will it always work? Of course not. It will most probably not work most of the time. There will be many things at play which can go wrong. Many things. Like let's just start with the original system is down. There is some maintenance activity going on. Sorry, your data is not even available for you to download. Right. Your executor is running somehow out of memory, it went. It's not even your mistake. Like whoever has developed the code, they might have a condition here and there which they forgot about and it blowed up the server is dead. Now, how do you handle all these kind of issues? So you have to start training your brain to think negatively. That once you have the happy path, then you have to think about what can go wrong and go berserk. What else, what everything can go wrong. Start preparing a list, right? For example, let's say, same example, executor failed. Okay, what happens if that executor failed? Do we restart? Do we restart from what it already downloaded? Is it a transient problem? Maybe the network had an issue. Sure, you're out of the 10,000 documents you downloaded, or out of the 10,000, 5,000 you already downloaded. Do you need to really restart the entire thing? Maybe we should have a checkpointing mechanism, right? And then if you think about, like, again, the kind of failure is, for some reason, the scheduler is running your sync. It's not yet completed. But it's taking more time. And let's say your sync interval is 1 hour. It's taking more than 1 hour, and just your scheduler starts another sync. Is that something that should happen if there's already a thing going on, right? So you just think about scenarios which can go wrong and actively start how we can handle it, right? So I talked about, in a sense, like failure in terms of checkpointing you can add. You talked about, like, in terms of multiple collisions of things. Maybe like now we can think in terms of performance. Okay, now we have like base level solution out, and for phase one, that's good. Suddenly, your entire system became very popular. People loved directly connecting their own apps in a 5 minutes, and data is ready to sync. So many people are there. This is where scale comes into picture. Do you always download the entire thing? Do you download the entire corporate data every 1 hour? Or do you want to only download stuff which changed or which got added now, right? So thereby reducing almost like 95% load. Initially, of course, the first one you downloaded the entire set. And then for the next time it ran, only 10 documents got created. So you only don't need to download those, right? These kind of intelligence you can think about. This is called the detailed aspects of things, and how do you make system more robust, resilient to failures, and maybe performance, right? But this comes second. First, start with drilling down in terms of ambiguity, reducing the scope of ambiguity at each level, and then thinking about the high level design, low level design, failures, and then in terms of optimization. So premature optimization is something, and the complex part which everybody likes to work about, like to begin with, you should delay as much as possible and ask yourself, ask the business that what we want to develop. Is it even needed? Right. So I guess that's how it works. Now, this is in terms of the original tech part, but at a big tech or any kind of mature organization, see, as I mentioned, they focus a lot more in terms of failures, right? So the failure is not in terms of just tech. Failure could be in terms of processes. Right? Sure, you can never have things which will work perfectly. Let's say a data has not ran for, let's say, 2 days, and customer is coming to you like, my entire set of documents is stale. None of my newer documents are available, or the data which I deleted is still there. It should not have been searchable. That's a bigger problem than new data not being available, right? So what do you do? So you have to establish processes in terms of debugging. Like if there is a problem, how do engineers, support teams, do they have a process document in place? Like, okay, whenever there's a new issue that comes up, do they directly ping the developer, hey, does it 2 o'clock in the night? Or could you create some kind of process runbooks where the support engineers first can try to debug as much as possible, gather information as much as possible whenever an incident happens, and then try to solve maybe 80% of the problems themselves? So you need to enable them to be able to do so. So create process documents, create tools, support tools, which will give them information about it. Okay, this sync mechanism ran at 2 o'clock. What was the status? What was the error? If there was an error, does it simply say I am failing, or it does give it a nice kind of information? Okay, I failed, but because there was a network failure. Okay, I failed because there was a huge fire, and I did not know how to handle it. Right. So this kind of information allows them to triage and maybe just fix the solution as soon as possible, or to even honestly, again, coming back to questioning yourself, is that even a problem, or was it actually a feature, right? That okay, we will not download more than 1 GB file. So like processes is something that you will think of, and then supportability and monitoring. And the last one, which also is important, not also, it's actually very important as part of entire checklist when you say, yo, I am done, is security and privacy. Whatever you have developed, is it safe? Is it secure that the data is not leaked or accidentally or intentionally? When I say intentionally, what if one of your developers themselves have gone rogue? So how do you put mechanisms in place that people themselves cannot exfiltrate data, right? Or you're handling customer data very carefully, or in production, nobody can even look at customer data. Even if they have to, let's say, for fixing any issue, they have to take approvals in place so that there are multiple people involved in giving an approval to make sure not one single actor can themselves start looking into, hey, what is Swapnil document he is creating these days? Let me see into his personal diary, right? So all of that stuff. So as I mentioned, requirements, try to think of the high level design, go detailed component, think about failures first rather than performance to begin with. So the system is correct. Then think about performance, then think about scalability, monitoring, which is equally important. The supportability, how do you make sure you can triage issues when they come up as fast as possible? And lastly, when you think about is compliance, security, privacy. So I think this allows you to get a whole 360 aspect when you say, oh, I have designed a system. So it's not about just the fancy tech part. It's about actually as you mature, as you become senior enough, your responsibilities, uh, purview of your responsibilities expands to this much level. Because you then, I would call as like are the owner or system of the system. Because the ownership doesn't mean a snapshot in time. That you build it this system and now you're gone. And they're going to the different greener pastures. No, you have to maintain them as well. Yeah, I guess. Yeah, that help give some color.
Yeah, that was really insightful. Thank you for sharing those insights. Now, let's open to the audience. We have received some excellent questions, so let's dive in.
Okay.
We have a question from Amit Trivedi. He's asking, what are your thoughts on AI powered coding? How do you think this impacts future of developers?
Hmm. I think everybody is wondering that question, right? So, I mean, these are my personal views. Of course, all of my the views are my personal, nothing related to the organizations that I'm affiliated to or working with. So, I think with time, I don't know. So, I think this is the same thing which has been said on multiple platforms as well. So if you remember, when we think about programming per se, there was initially called machine language assembly code, which was almost like binary. You were writing zero ones, and engineers that time used to like even write on metallic sheets, punch machines. And then we have evolved a little bit higher. The first high level language came is C++, which said if something, do this, else something. So it's almost like English, right? And then Java, and then big things came like Python, which are so a lot easier to program in, right? And then we have these visual builder tools like Wix. I don't know how you can make websites by dragging and dropping, and there are more website bubble and all that other. What you are seeing is a level of abstraction, basically. So we started with something super complex, super detailed, and then we moved a little higher, where we said, I don't care about the actual implementation, how it happens. I'm giving you a directive, a declarative way that this should happen. So the C++ compiler does the job. When you say if something, condition, something else, this condition, this result. So the compiler internally is doing moving the data from your CPU registers or in your metallic. So nowadays, when you use a laptop, do you really care how Google Chrome works internally, how it talks to another website? No, right?
No.
We are working over abstractions. So internal. So just like that, with these AI coding tools, what is going to happen is they are creating an abstraction of a lower level coding,
Okay.
right? So when we think about, okay, I do simpler example. I'm doing some coding where like programming, writing some program, and then I have to take, let's say I'm searching for something, I got some results, and I have to take the best result out of it. Okay, but also group them into containers so that each result has a type, that it's audio, video, mail, drive, whatever, and then each has some kind of a score mechanism, how relevant it is to you. So in normal life, what you will do is you will write a code to loop through each value, then you'll create a bucket and then sort it. You'll do all of it yourself. writing code, whether it's your whatever programming language it is, doesn't matter honestly. But then with the moment you are about to do this, you define a function called bucket and sort. Suddenly AI Copilot, GitHub Copilot or any AI assisting code is, do you want to do this? And it generated the whole code. So it's not
Okay.
replacing you per se, right? So it wrote that redundant code for you more or less. So it's now you're operating on a higher level abstraction. So you were thinking about, I need to like basically give search results to the user and I will fetch the data from database. And then ultimately, you know what, it's better to bucket them. I could have simply done a sorting over all the scores. But let's say for some goddamn reason you have watched a lot of videos and whatever topic that you're looking for has lots of videos. So all the top 10 results would have been just videos. But you are as a designer, you're like, you know what, I don't want to crowd the entire thing as just videos. Maybe have some little bit from each bucket. Right. So you were thinking as a programmer now, a designer at a higher level now. But the actual bucketing and sorting, you're like, okay, I know that. I know I can do it, but I do not want to do it. So the AI assisting is actually assisting you in more mundane tasks. Right. You're still a programmer. You're designing because programming means take some logical blocks, combine them together to build something bigger using those blocks. Programming, you have a simple some a set of constructs, right? If I'll switch whatever classes, whatever, and then you try to build a server or a client based on that. Here again, you're doing the same thing. You're trying to build a search service. We gave an example. And when bucketing is sorting your design idea, maybe that's better for the user. But the actual bucketing and sorting is not done by you. You are now asking the AI code to write that for you. Now, so that's like will save time, and this is where I think things are going to go, where AI assisting coding will not replace coders, but replace mundane, easier parts of the coding and provide you an abstraction. So you become more like a director. You're still designing the system, but the smaller level things will be done by the AI. And let's say even in the cases of, but so this will be more generic because AI is dumb in a sense. It's trained on existing data, so it will write the code which it has seen in the background. Most of the time, it will
Right,
be a good
right.
code, but it will not be the best one clearly. And then you are smarter than AI. And then you realize, you know what, this sorting mechanism is too slow. I know something better, which is faster and is more tuned for my preference. So you can go ahead and write it. So it doesn't mean that you don't need to know this stuff. You still need to know. Otherwise, you will just simply just rely on that AI assistant. You are in for like, I don't know. It's, you won't be able to harness the best possibility out of it. So you see, ma'am. So I guess you will put it at a higher level abstraction. So the result of this whole change would be that as developers or as people, we'll have to upskill. So if we are in the lower bracket where we are just writing those base level coding, then I would say it's high time. You should start upskilling yourselves. Think about higher ideas. Think in terms of designing overall systems. But anyone who is just doing just like for loop and sort like the level of coding per se, which earlier anyway they were trying to reference it from other websites or whatever, that is not going to fly anymore. So you have to operate. It's just like machines came into picture, right? So if you're just let's say putting two things together, if a machine comes and puts those two things together, then there's no difference. Of course, the machine is gonna win. But if you know how to put the two things together, you are just telling the machine to put these two things together. Yeah. Yeah. Yeah.
So, according to you, AI is helpful, but you have to, most of the things you have to do yourself. AI आपको छोटे-छोटे चीज़ों में हेल्प कर सकता है, बट अल्टीमेटली यू आर द डेवलपर्स, तो आपके ऊपर ही डिपेंड करता है.
But you have to upskill yourself also to operate at those higher levels. That lower level band will be taken up by the AI.
So, audience, please ask some insightful questions. We have another question from Sahil Rathore.
Mhm.
He's asking what kind of experience need in front end Angular developing to get growth in career.
That's too specific. Okay. So, lucky for you, I'm a full stack developer, so I can answer that question. So, see, I can give you generic advice, and I think what has worked for me. and I hope it can help you at least some give you some perspective. So the thing is, don't tie yourself to one tool, one technology, one framework, because they will change eventually, right? Like JavaScript is the only language. Nowadays, there is a web assembly also coming to which was originally and still a majority of the portion. JavaScript is the only language which works in the browser, right? Then framework came into picture like Backbone.js, and then Angular, and then React, which is the best so far, and because it introduced a groundbreaking technology of virtual design, right? But I went through all those phases because I'm very entrepreneurial, and I worked with two startups in college time. So I worked from basic constructs. Just a second. And what has remained the same is the logic. So you need to understand, because each framework is trying to solve a problem for you internally. What problem is the generic pattern? So if you have to build a website, there is a page. When you click something, you go to another page. Now, earlier as developers, we had to build all that routing mechanism ourselves. What is that page? What is the content? Okay, each page has header and footer and then some main content. So you know what? Maybe we have a thing called skeleton, which already has header footer. You have to just specify the main content. So this is what framework is trying to do for you. Generalize those patterns. Each framework makes some choices regarding how those patterns work into picture, right? So you need to learn. Let's say in Angular, when Angular is prescribing you this and that, you need to understand and go under the hood now. So this is where you need to go into the abstraction now. You have been using Angular so far. You have been using binding this and that, and looking into how to make Angular perform better. You need to see, okay, why does this technique actually make the website faster? Then you will learn about the internal details, and those internal details are going to help you whether you create in React, whether you create in Vue.js, and it's going to stick with you. And that's when you will become generic. Like you don't care whether it is Angular, sure. Well, but oh, you need a React website. Great. Let me read up a little bit. It's the same thing more or less, because that's what you will feel once you'll start learning React, and you're like, I understand the idea behind it and why for some use cases React is better. And for these use cases, you know what? I think Angular is going to help, because there's no silver bullet. Every tool has a trade-off, and that's where, as a senior person, your job is to be, which is to evaluate those trade-offs. Yeah. So I would suggest, like when you say what to do better in Angular, I would say what to do better as a front-end engineer. So go into the details for JavaScript, understand how asynchronous mechanism works, how is the event-driven loop works, how do you work with promises. When you think about performance, how do we make sure there's no memory leaks, clean up things, how to make website performant, right? Make API calls. As I said, think about what all things can break. So when the shit when it breaks, how exactly do you handle it? Let's say API failed, then how do you do? Do you simply raise your hands, or your website give a nice error message, give them let's retry, or you auto retry? So think about all those mechanisms, which are going to stay the same whether it's React, Angular, Vue, doesn't. So I would suggest, and that would actually, just as last thing, that will also help you foray if you want to later as a backend engineer. So Node.js is the JavaScript-based server framework. So once you grasp all these fundamentals, it would be smooth sailing for you to go to Node.js more or less, because the fundamentals remain the same again, right? You're on mute, Shivangi.
Thank you for sharing that. Audience, I ask you to write your questions in Q&A section. And we have another question from Chetan, who is asking, I am facing one exception issue with C++ big project from the last 1 month. Whenever I debug code, it goes into out of scope. How can I resolve as a beginner in coding?
Okay, so I mean, like, you need to then read a book. This is more like I guess like for always do a course proper, understand the fundamentals. So if it is going out of scope, I'm not sure that have you heard about uh, scoping rules for C++? Because it says a lexicographic scoping. You need to understand all these terms and the mechanisms of each language, right? Now, this is a very specific question, so not sure if it's applicable to this broader audience here. It's a very specific programming question, so I'll avoid, please avoid programming level questions. We are here to discuss more like design level, higher level abstract. But yes, I would suggest like go ahead and take a proper, because that's what I did. When I wanted to learn React, I was like, okay, you know what, that's my job. I always go a little bit deeper, proper course slash book. You should read books, right? Once you have the understanding of overall aspects of the language or the tool that you're going to work with, or a framework or the technology, that's when you'll have some idea how to like navigate whenever there are issues. Because if you have, let's say, done a base understanding, then anything outside of understanding you wouldn't have any idea, which is also sometimes fine as the time permits. But then go online, you will find solutions for these kind of problems. Yeah.
So he has also asked also how to manage senior developer position as a beginner in coding.
I think you have already answered your question. How can I think that the only way is like actually level up, whatever is the gap. So if as a senior developer, but you are a beginner in coding, then why not learn? Take courses, right? That's the only way. So you have to pay the tax slash the investment, right?
Right. So we have another question from Veena. She has asked about data science. Some valuable insights about this. What about data science?
What kind of insight are you looking for in data science?
She has just okay. We'll skip this question.
I can maybe
We
give
have
you like data, like in data science, again, there are two types of aspects. One is analyzing data, and which is, I guess, using tools, right? And the other one is going into more like models and building your models. So depends where your career path you want to take. And I am not a expert on data science aspects, so I can't. I think I'm not well positioned to answer this question. But as I said, there are two forks. One is more business facing, and the other is more hands on in terms of mathematical modeling and so. So you are generating the actual model and working with the existing models or retraining them for your use case. And other is like you just using tools to see which area do you want to go into for into your goals.
great point. We have another question from Raghuram. He has asked, "What is the future for Java? Because some says it's no longer used in coding jobs, and will it be helpful in building AI?"
But Java is universal. Like it's like equally feature rich at the same time easier to learn compared to other languages. I mean, see again, like I said, you need to start thinking outside the box now. Don't constrain yourself to one framework, one tool. So even in Java, if you have learned Java, understand like when you have to do software engineering, what are the design patterns that come into picture? I don't know if you have heard about this thing called gangs of four design patterns. They have published common patterns. And the beauty of patterns is how does the design pattern, like even when I started reading the design pattern, I realized, oh, this is something I built myself. Because whenever I was stuck with a problem like that, I realized I need a solution to what is the best way to solve this. And I thought of something which made sense to me and seems like many people thought the same way. And that's how it became a pattern and published, right? Singleton patterns, like command pattern, observer pattern. This is something even like simpler if you start thinking about a problem long enough. So you need to also immerse in problems. So I think when going back to complex problem, how do you tackle complex problem is you keep hitting at it. You don't give up because it's complex for a reason, right? It's not an Instagram reel that you just think about, watch it, and done with it. You have to keep at it. You will fail initially. You'll be like, oh my god, I don't know how to solve this. Then you think, well, okay, you know what? Let me solve this part first because there are two things I can see. And then in the other first part, you're more or less looking for my idea. In the second part, you're like, oh no, I don't know how to do it. And then some fine evening, you're like, oh shit, you know what? We can divide into this way. And if I think about a scheduler, an executor can change based on the apps. The scheduler can remain the same. That's how it happened to me, right? So this way is same thing. So even for when I see, to take those examples, so going back to let's say Java here, when you're trying to think about a Java application, how can you make your code flexible enough that new features can get it without disrupting the entire code again, right? So you read about patterns, and then you will realize, okay, this pattern has not Java written here anywhere. It's a pattern. It's a coding pattern, a software design pattern. Principles, right? Everything is the same. So even if Java tomorrow, let's say, goes out of the picture because there's another new framework which has come into picture, which is AI powered, doesn't matter. The patterns will remain the same, right? And this is still true. Even so, I can program in JavaScript, Java, Scala, Rust, doesn't matter. The patterns still remain the same. Yeah, syntax here and there, lower level will change a little bit because, of course, it's a different language. And that's how we work. So think of all how you can be awesome when you solve a problem. And when you start thinking in that direction, which is again, you can be awesome, doesn't matter. Do you just say how can be Java awesome? No, you can be how can be awesome. The same pattern start repeating again and again, and soon you will find yourself in a position where you don't care, right? Which you're not sticking to one tool, one approach. So in same way, in Java, think about how to solve for performance, solve for better design principles, and solve better API. How to design a better API, the API interface of a library or API of a FTTP API. They will remain the same, and then soon those principles you can port forward to like the Golang, Python, whichever language you are going to work with.
Oh, great point. So let's move on to our next question. Mohit Patel has asked which technology you are currently working on and how your day looks like.
So, hmm, okay. I mean, as I said, I think if you got an idea that I don't like talking about technologies and frameworks because I really want all of you to elevate yourself above it, right? If you are going to stuck with the technology, then of course you are going to get replaced because someday some AI will catch up, who will become very good at that technology because it will become redundant for them. You keep doing the same thing. Now, coming to technology slash team, like as I said, I am on the internet search team. Intranet means inside a network. So here we allow companies to search on their private data. So whenever you search on the Google, you're searching on the public data. But let's say as a company, you have so many announcements, emails, documents, chats, uh, website document, which has its own content, right? So you want to search across all of them in one place. That's our product, and I'm working on that. How does my day look like? Well, in the morning when I come in, I love having a breakfast. And then somebody gave me an advice way back, and which was to never start your day directly going into work per se, or like just start doing your tasks. No, start your day by learning something. So dedicate those half and 1 hour, totally fine, to just like read random stuff. Doesn't matter have to be like specific to your job. Read anything, like whether it is about, let's say, psychology or like what is happening in the world or your favorite guitar player. You want to see what is the new latest song they have played. Like basically indulge yourself, scratch your curiosity a little bit. That's how you will learn how to take basically give some time, give some thought, have your own thought, think about what's going on, right? So this it gives you information to think about, new information. So I would say that is one. And then after that, of course, first plan your day. Okay, and I have a like a task list. I have, by the way, I might sound like a much more managed person. I am not. I was not. After COVID, only I have become a little bit more disciplined. I was a chaotic person, which keep everything in my head. But now I'm keeping like a small to-do list, and I've categorized them in terms of office, home, personal stuff, whatever. So this way, I do not let things uh, fall out of cracks, like something which I have to do, I forgot to do it, right? But whether it could be replying to an email. I don't want to reply right now, so I had it in my list. I have to reply it by tomorrow. And then first day in the morning, I look at all the pending laundry list, try to see what I want to really do it today, and then snooze to tomorrow, other stuff. That's how you have to first plan your day. And then just go around the day, work on your stuff, like enable people who are blocked on you. And I guess that's it. Come home, spend time with family, friends. And if somehow, sometime you feel like doing some exercise, do it. I would very highly suggest being a little active. Doesn't have to be full blown going to a gym or anything, but that's great if you do. but at least be active. That's, I think, what's important these days.
Wow, great tips. So we have next question from Harsh Singh. He has asked if you could travel back in time and give yourself one piece of technical advice at the start of your career, what would it be?
Uh, so it will not be a technical advice. I guess technically, just like you learn at your own pace. It's okay. So, like technically, I think I was always wanting to curious. I would say that was one part which is good about me. So I, I was very curious, and I used to read and like try to experiment a lot and failed a lot all the time, trying to build something only to realize that it was not needed. So that is where I would say give that advice is like, okay, whatever you're trying to work, better to first clarify what you want, what whether it is needed, is it really somebody's problem, and at the same time, I would say also learn a little bit more on the soft skills aspects, which is, as I said, I was very chaotic initially, so maybe a little bit more discipline in terms of what you need to do, and better to like respond to stuff which is, as a young engineer, I was very bad in terms of managing like what is expected out of me. I used to like working. I was good at working, like solving problems because I used to dedicate a lot of my time, keep at it, never give up. But at the same time, anything which is more soft skilly, let's say prepare a report, which is asked by my manager, I was like, yeah, I don't like it. I don't want to do it. And then at the end, our manager would come to me, I have to get it done. I have been telling you for the last 1 week, what are you doing? And so what happened is all the nice, good reputation which I built gets tarnished by one small act of my negligence. So I would say that would be one technical advice, one advice per se, is to be, I'm not sure, I think many people are already good at it. It's just me. But yeah, I would say that would be one thing that also focus a little bit on your soft skills, figure out how to manage expectations, and at the same time, work towards also clarify. I love to solve problems. So basically, as I said, clarify requirements first. What do you want to solve for, and make sure that you go in the same direction.
So we have another question from Veena. She is asking, I am from a non-IT background and now learning data science. How should I excel in this field and should we depend on AI tools?
Okay, I'm from America and now learning data science. Great. How should I excel in this field? Learn. I think you have already answered your question. So when you say excel, I mean again, like whichever field you're working with, go talk to some expert in that field. Ask them, okay, if I have to excel here, what all skill sets do I need? Where do you see a person excelling in this field who's having these skill sets, right? So get real data points. Sorry, I'm not an expert in the data science per se. So if, like I can give you, as I said, there are two paths. So if you are on the business side of path, then I would say they would give you better ideas that learn Tableau, I don't know, different types of tools, right? And if you're on marketing side or if you're on pricing side, I don't know, whichever domain it is. So ask an expert in your domain that when you say data science, why are you learning data science? Ask them that, okay, I am trying to be an expert here. What would be your skill set that is needed? And then from map, that is what I call backtracking. So from where you want to be, ask an expert how to get there. They will tell you need to have this. Then you ask another person or you figure out on the online, talk to people that if I have to achieve this, what should I need to do? So if there are 4 skill sets, for each skill set, you see if you're already good at it, great. If you're not, then take a course, join a course, read a book. And not just one course, one book, read multiple courses, multiple books that you get a lot more information. Practice that information, right? And that's how you'll become better. Not better, you'll excel at this field. And you will keep excelling only when you keep upscaling yourself. There is no stopping to it, in a sense, I would say. And whether we should depend on AI tools. See, the thing, AI is an assistant, and it's here to replace redundant aspects. But how do you know what is redundant if you're not yourself not an expert there? Then, if you yourself are driven by AI, then you are going to get replaced, right? So, I mean, that's I think is a little stronger statement. But what I'm trying to say is, if you yourself are depending on AI tool, and that's all you are doing, then what is the difference between you and the AI tool? Nothing, right? So there has to be a value add that you are doing using AI tool to achieve something bigger, right? So if the AI tool is able to generate images, what are you doing with those images? Okay, so you built a marketing firm which, based on clients' requirements, generates PR images. Oh, now you have added value. You're not a dumb AI tool which is generating just images. So you are not a person who's clicking a button and generating image, right? You are actually have built a business on top of it, and you figure out from. So you have built another overall business where you ask the customer, what is the PR content, what is your category, right? And then you write in the AI tool to generate image, some prompt or whatever, which you have learned that this prompt kind of works. So you are adding a value there. So here in data science, I would say first learn the base stuff. Only when you learn base stuff, when you realize, this is now becoming redundant. You know what? Let me use a tool to make me faster, and don't do this redundant work again and again.
Thanks for answering that. We have a question from Vasundhara. She's asking, what are the key skills that engineers need to develop to solve complex technical challenges? What tools or technologies do you find essential when solving large scale technical challenges?
Mm, So in large scale, I think one thing that all engineers need to learn and understand is when we talk about performance or things which can go wrong, the central theme, the central character there is a database. So if you don't know how database works, and again you're depending on database as a tool of magical silver bullet, so somehow works. When you are depending on the database to somehow work, you need to know how it works internally. Then only you know okay, where it crashes, where it does not crash, and then you know when you're trying to build a solution that okay, you know what, in this edge case, it's going to crash for sure, right? So as I mentioned, again coming back to the original data sync story, there are multiple executor working, but now we have we have paralyzed the executors, right? So we want maximum performance. So we can, you know what, we'll not have one, we'll have 100 executors. But if two executors are starting to sync together, how do you make sure that they do not overstep on each other? This theme that they have common is a database. Now both of them can start working on a sync themselves. So how do you tell one guy somehow that the other one does not? So you think, oh, database has a thing called locking. Okay. But then you need to understand that what if your executor dies? That the sync is always locked. Nobody's going to work on it because no other executor can pick it up. They need to know, okay, database locks, you can do some kind of expiration to think about all this. But expires work this way and that's where there is a transaction, and transactions have multiple isolation modes. So when we think about, everybody uses transactions like some silver bullet, but they don't know that there are deeper levels of transaction. And databases always love to do marketing very nicely. They say, oh, we work all the time. They do not. So you need to actually ask the hard questions, and then you realize, oh, it does not work all the time. So my sense, as I said, would be to, let's say, in databases, you need to read some. There's a book called Domain Driven Applications. So that goes into internals. So read about databases, how they work internally, how transactions are done. So that is like a cornerstone that you have to deal with, because databases are your sources of truth of what is going on in the system. If the source of truth itself fails, then the कुछ हो ही नहीं सकता, right? So
Right, right.
database is something that you should think about. The second is like always when nowadays it's no more about that one system is working on it or isolation. There are many systems interacting with each other, and how do they interact is through an API. So learn about how to build nice APIs, because again APIs will fail. Then what do you do when an API fails? How do you let the client that okay, I failed, that's fine, but how can I do something about it? So you might know, oh, you know what, you can tell them that it's a transient failure. Okay, I ran out of memory, but that doesn't mean I died. I can serve another request maybe in a 5 minutes later. So tell them the API, you can retry your request 5 minutes later. This way the client will know, okay, let me not give you retry request right away, because of course it will also fail. So this is how you're starting to give more information to your client system, and think about designing nice APIs, right? So learn about API design, API best practices, because if you develop systems which interact well with each other, Then whenever there's an issue, you know how you can handle that issue. If there is no information, then the client also can't do. It can just make guesses. So API design, databases, and in the third one, which is advanced, is distributed systems. So look at like replication, look at sharding, partitioning. Those are kind of advanced concepts, not needed honestly all the time because you are not working at a level of the actual. Like if it happens, then great that you are at that level. You're building 1 billion users are using your product, but rarely it happens that actually that many users are using the product. So those hindsight always come to the picture. Don't do premature optimization. Only do it when it is needed. So I guess yeah. So these kind of in terms of tech, basically, I would say. So databases, APIs, and for performance, anything in terms of whichever app you're writing, think about performance. Think about how you can do better error handling.
Oh, that was insightful. We have another question. Google has a intense hiring process for engineers. Can you share some insights into how Google evaluates problem solving skills during its hiring process?
So I mean, I cannot give exact details of anything like that, but I'll take you generally how any mature tech company, when they evaluate hiring, what do they look for? They look for problem solving, right? So now, normally, I think this is already there are 10,000 articles, videos on YouTube and all that, system design, lower level coding, algorithm rounds, the same thing again. But ultimately, at the end of the day, they're not looking for one solution, right? There is no one solution to any problem. There are many solutions, and each has trade-offs. So the interviewer is your friend. Ideal good interviewers, when they interview, we want to hire you. We do not want to reject you. We want to hire you and see first to do that, we need to know your strengths, that what you're good at. So we are also there to help you. And what we are looking for is given a solution, how detailed you are in thinking about again to solve it, what can go wrong, the trade-offs for each approach. Let's say one approach is able to solve in, let's say again going back to the whole database sync thing. You thought about only just somehow syncing the data. Now, what about if it fails? Do we sync the data again and again? The entire thing. So this is level two. And this is what distinguishes someone from who's detail oriented versus someone who is just trying to get the thing done, right? And doesn't have a bigger mental horizon. So I would say practice in terms of that expanding your horizon when you think about a problem. Like really immerse yourself. And so in a hiring process, they just look for your thought process. They look for this higher level thinking that whenever or not only solve the actual problem without any cases or any issues, but at the same time think about how it can fail and how what are you doing in terms of that.
So I have a question from my side. So what are your interests apart from your job, and how do you manage not burning out due to work?
It's an excellent question. I think so what are my first? I would say okay. My interests. So I'm very entrepreneurial. So I like this building stuff, and I like so my main kick is like I like to build solutions slash tools or anything which allows other people to create value. And ideally, if they can build on top of my thing, then I am more than happy. This means I create someone's life a little better. So that is my kick to, and which is why I love programming. So I never loved Java or I never loved C++. Think of those things as tools to achieve something, right? Right. So you think about okay. So the first thing that I built in this is funny. The first one was a game in 11th class because I loved playing games. I was like, why I want to build my own game? So just for fun. And then the second thing which I built was a thing called bunkometer in first year because a friend of mine. So actually, at that time there used to be like the colleges used to fail people if they had attendance below a certain threshold. So that person first time studied in his own life, entire life in a semester, and then he got a failure, like a F in one subject because his attendance was less. So I was like, let's build something called a bunkometer where everybody will at the start of the session they have the timetable, right? So bunkometer will scan the timetable, At each a day, you can mark that did you attend the class, you did not attend the class, or you send someone to do a proxy for you. And then it will tell you, okay, you have these many holidays left, you can take this many holidays and you should not. Like, I'm just trying to tell you, like, this was my first app. Then I built something like Swiggy in second year, 2010, that time, because we wanted to help people to order food, right? And know that there was a nice restaurant around you, but nobody knew. Because that time we used to call restaurants, and only few restaurants had that facility. Anyway, so coming back, so this is like one of the things that I like. And apart from that, I like spending time with family friends, and I like gymming a little. Actually, I like gymming. I would not say I really like it. It's mundane as hell. It's boring as hell, but I like it. Anyway.
Wow.
So these are the things I do, and for burning out question, I think that's becoming a lot of. It should be addressed, and it should be something first. If you feel that you are burning out, I myself had like 2 3 years of burnout because I was at some place which was had a toxic culture. So I would say first understand that you might be a case of burnout. That would be step one. Step two would be to see what's the reason behind it. Now, as I said, in my case, it was toxic work culture and lot of work at the same time. So it could be, so that was like previous companies, and again, the personal opinion, so it could have been anything different. But in your case as well, figure out what is it. Is it some kind of work related thing? If there's too much work or there is less work, that also could be one of that. You just don't have anything and you're like, what is life? What am I doing in life? And that is not giving you any kind of motivation whatsoever, right? Or you are alone, maybe, or maybe I would say the work that you're doing is monotonous and you don't see it going anywhere. So it's not fulfilling your purpose of satisfaction or purpose of life, or whatever motivates you, right? Or whatever work you're doing, if the work life is great, work life balance is not there, or the work is great, manager is great, there is not too much work, it's nice work also, but you don't like it. So then you have to change, right? So figure out that what is the cause behind it, and I would say take active steps, because mental health, I think, is something super important. So think about it. Surround yourself with people who are positive and who appreciate you. And also, it's a give and take, by the way, folks. Like, it's not about that you only expect, you also have to be there for people. So have those nice safety net around you with good people, genuinely good friends. So spend time, and you have to, as I said, you have to spend time with them, with family. So keep those people around you, and ask for help. Ask for your manager. Ask for your teammates. There might be some who are actually genuinely good. Maybe your sister team manager. Talk to you what is going wrong, and be receptive to feedback. There might be something wrong with you as well. That could be the start of it. That may be that you don't like the work. You're just blaming everyone else, but ultimately it's you who's not liking the work, and which is why you're not doing a really good job. And everybody is now saying that you're not doing a good job, which is where you realize, oh, but you start with it that, okay, might not doing a good job because I don't like it. So maybe I need to change my stream. So, like,
Wow.
I mean, yeah,
Yeah, that was a great advice. I think following your passion is the key to success, I think.
yeah, it's also overrated in the sense that don't go into stress because you don't know what your passion is. Again, uh, so
Right.
I would say, because I saw a lot of people talking to me about it, that we don't know what to want. So that's fine. I mean, what you need better you can do is like spend time exploring things then. Right? That's the half the battle one. So if you don't know what you like, sure, but you like money, I guess. And then if you like having good car, then maybe if this job is giving you that and is not giving you stress at least, then this is also fine. So don't overthink that aspect. That's what I'm saying as well. Explore at the same time. Maybe do an
Right,
internship or
right, right.
do a side project in your free time. Make that free time. Do a side project. If you like music, do a side project in music. Side project in the sense actually learn guitar, and then you realize, oh, actually I want to do this. Great.
Right, right. So, before we wrap up, do you have any final thoughts for or advice for engineers who are looking to solve big challenges?
Mm, of course, as I said, be curious in life. So learn, and when you say learn, of course, put that into practice. Then So whenever you learn new concepts, by the way, when it comes to learning, you need to still feel motivated first to learn. And that will happen when you were passionate about that problem. And again, doesn't have to be tech, by the way. It could be a business side problem as well, that the product literally sucks. The user needs something, and whatever we have built is totally perpendicular. So you might talk to your product manager or become a product manager, do an MBA degree to actually figure out what is the customer psychology. So you now you're passionate about solving the customer's problem, whatever it is, right? So first become passionate, then become curious how to solve it, then figure out how to learn or become better to actually be good at solving at that. And I think that's the main key, and that will automatically make you an awesome person.
Thank you so much, Swapnil, for your time and sharing your expertise with us. And thank you, audience, for your fantastic questions and participation. We hope you all enjoyed this session and took away some valuable insights. Thank you, Safir. And for audience, stay tuned for more events like this. Up till next time, and keep exploring and keep solving. Have a great day, everyone.
And enjoy, people, enjoy your weekend. Bye.